What we're going to do is just have somewhat of a presentation for the first little bit, so they won't be missing any code per se. They can always just rewatch this if they need to. So, all right, we're going to get started now. So let me share my screen here. What we're going to be talking about today is how to use multiple managed object contexts and sort of some implications with how to use concurrency correctly with core data. So we're basically going to refactor essentially what we did yesterday a little bit, and it's honestly not much code, but we're going to go into sort of the why we need to do this in order to sort of make our code here a little bit more performant, and especially sort of future-proofing it if we were fetching especially like large amounts of data. So by the end of the lesson today, you're going to have a really, really good, like way more than foundational knowledge of core data. This is stuff that some people don't learn until, much later. This is something that I never learned about when I sort of first went through learning core data. So you're getting some really good experience, and if you can get really good at this, then that'll be super helpful for you when you're on the job. So let me just pull up my slideshow here. There we go. Okay. So we're going to be talking about multiple managed object contexts, and the first question is, why do we want to do this? Why would we ever say, okay, well, it's not, it's not enough the way that we've got our core data stack set up with just the persistent store, the coordinator, and the managed object context. Why do we need to go outside of that and essentially, do more work and have that be more complex? Probably the biggest reason is because you can have one context that's kind of dealing with like fetching data in the background and saving it, and you can have another context that's sort of related to UI related things. So like, for example, our fetch results controller is using one context, and we have another one just completely just fetching information in the background. And it's not like preventing them both from working at the same time. And we also make it so that our code is a little bit safer. And I'll kind of get to what I mean by that in a few minutes. But we're just going to talk about the conceptual here. So let's look at this. So this is sort of, this is basically just like flip 90 degrees from the way that I generally draw this, but the setup is essentially the same. So we've got a persistent store, we've got a persistent store coordinator, but instead of just one managed object context, we now have two. So what does this mean for us? How would this actually work in practice? So, oh, you know what? I will be right back. It's just going to take me like 10 seconds. I just need to grab my iPad. Okay, sorry about that. Just gonna try to draw this out so it'll make a little bit more sense and like illustrate or annotate things. Okay. So we could say that we are going to maybe have this context be for fetching tasks from Firebase. So that's going to be its job, is when we fetch tasks from Firebase, we're going to put them on this managed object context. So when we get those changes, we're going to write those changes to the managed object context. And then when we call save, it's going to throw them up to the persistent store so that can get saved to the persistent, or sorry, throw those up to the persistent store coordinator so it can get saved to the persistent store. But then something interesting happens or we want something to happen, when we actually make those changes, what we want to do is we want to say, hey, this manage object context over here needs to know about those changes. So I'm going to say that this mock is for like showing tasks. So for example, like I'm just going to say like our fetch results controller, for example, is going to be looking at this manage object context here. So what happens is we merge these changes over so that the fetch results controller can see those changes. And so those get thrown over to here. So there's kind of like a copy of, or at least they show the same information. If you remember yesterday, when at the very end of the guided project, I said, I asked why we don't need to like reload the table view in order for the things to show up. If you remember that, that's because the fetch results controller, as soon as it sees something in this manage object context, it immediately will set up cells, you know, add them, delete them, whatever. So in order for the fetch results controller to do that, it has to be actually seeing some changes. And if all of these changes are happening on this sort of background behind the scenes manage object context, it will never be able to see those changes. And so very often you want to do a merge like this. Does that make sense conceptually? Are there any questions about this? Kind of how the setup works? Okay. So going back to the why.
Do you mind?
Yeah, what's up?
Do you mind going over the merging aspect of the two mocks? You were saying something about how the fetch request controller actually monitors any changes to actually make the changes on its own.
Yeah, yeah. So those are kind of like two concepts. But the fetch results controller is just always like looking at this mock, and then whenever it sees these changes over here, what it says is, oh, I need to like, you know, I'm just going to say change the table view in some way, right? Like make a cell, delete it, depending on whatever that changes. Yeah. That doesn't necessarily have anything to do with multiple contexts in this merging per se, but it's just that if we are sort of making our actual changes where we fetch the tasks on this background context, and we were just to directly save them, then there would be, if we basically didn't have a way to merge those changes over, then the fetch results controller would never see those changes because they wouldn't be happening on this manage object context. Does that kind of clarify that a little bit? Mark? Well, maybe he's frozen. Actually, I'll keep that one. So I guess really going back to the why, it would be, that is the most common thing where you want to get some data from somewhere, you want to import it from somewhere, generally like, you know, from a network call or whatever. And this way you're doing things on a background context, and sort of what I'm implying here is if you make a background context, you're also using things on a background queue, a background dispatch queue. So it's not locking up that sort of special main dispatch queue that is sort of in charge of UI. So just as an example here, if we look at the, oh shoot, sorry, still drawing, here we go. If we look at our core data stack here, we said we make this main context, and we're changing its name from view context to main context. Either way, this should help you think, oh, this is the context, this is the manage object context that's specifically for you know, UI related things. So the way that this works is whenever you create a manage object context, you have to say what dispatch queue it should run on. So for us, when we set up this persistent container, it just sets up one context and it just happens to be on the main thread, on the main queue. So the implication with that is if we were fetching a ton of data, hundreds and hundreds of megabytes, and we were saving that, there's the potential that we would lock up that main thread for the amount of time that it takes to shuffle all of that information into core data, into the persistent store, and it could potentially lock up our UI, the way that we wrote our project today. It would take a lot, but in theory, it's still possible. So what we want to do is try to get off the main thread and use a separate context in order to make it so that we are not potentially locking up our UI. So that would be the biggest reason to use something like this. So as far as the code goes, it's actually really easy now. Again, since they added this persistent store, they also made sort of these changes, merging changes, really easy. It used to be that you had to set up this whole observer pattern thing going on between the contexts. And now all it is a single line of code that you have to add to your core data stack, which is this one right here. Just this container.viewContext automatically merges changes from parent equals true. And what that says is, hey, whenever my parent, which I'll get to what a parent is in just a second, whenever my parent gets some changes, go ahead and give me access to those changes as well so I can see them. And that's essentially how the merging goes. So what's actually really happening here is when we have some changes on this background manage object context, it gives its changes to the persistent store coordinator. And the coordinator is actually what you would call the parent in this case of both contexts. And so when we've said over here on our view context that it should automatically merge changes from its parent, then as soon as that parent gets some changes, those changes go down here as well. The graphic doesn't quite do it like accurately. It's not like those kind of go from one context to the other in this case. It's just that the parent grabs those changes and gives them to this view context. And that's just sort of an automatic thing that happens. And that really, that's all you have to do. When you have multiple contexts, just to get those changes, you just set automatically merges changes from parent to true, and they'll come down. Are there any questions about this?
So would you use a MOC for basically any page in the app that requires input from a user? Is that the best way to do it?
How do you mean? Can you kind of explain?
Like if you have a sign-up page and you have one background context for that, then you have your main. Should you also have another MOC for another page that requires some form of input? Or
oh, I see. No, generally, for many use cases, you're like having two like this is probably plenty. For example, like in that case of, maybe it's a user sign up page and you want to save a user object. That's completely fine to save something like that because it's so small on the main context. Like it's not a huge issue. It's not such a huge issue that you need to make a background context unless you really wanted to. It only becomes an issue when you're fetching or when you're potentially going to be saving a ton of data, right? Like from fetching things from an API. It could be that the API gives you a couple kilobytes of information, or it could be that it gives you an entire JSON list of every, I don't know, whatever in the world. And it's just this huge amount of information that you need to kind of make sure that you don't lock up the UI with. So this is more than anything like preventative at this point. It takes quite a bit for you to even really notice this on, even if you are saving things on the main queue. But that said, there's always the case when, there's the edge case of the person that wants to fetch a billion things and, they have a bad experience because of it. So writing it this way is honestly not that much work. You'll actually see the amount of code we write today is very small. And I just want to go through this so we know kind of conceptually what's going on. But as far as setting this up goes, it's not hard. That said, so Austin, to your point, because it's not hard, it wouldn't hurt anything either if you wanted to make a new context for everyone, but at the same time, it's probably overkill. So
yeah, I'm just wondering if it's just plenty to have two. So that was like my main, I guess, pondering of that. So you answered that perfectly for me.
okay, cool. We'll kind of get, I want to jump back to this a little bit once we actually go into the code, because the way that this works with the background context is a little bit interesting. But on a conceptual level, this is what's happening.
Spencer, just to get some clarification. So at some point, however many contexts you have, right? Mm-hmm. At some point, they're all going to be identical and contain the same data.
Yeah, they can, for sure. As long as you say that you want to merge them, then yes, they would.
Well, they have to, right? Because that merging is a prerequisite, right?
No, there's nothing saying that you have to merge these changes. If you want, you could just directly save those background changes into the persistent store. The only reason that it's sort of a requirement for us is because our second context, this view context here, just needs access to those changes to see those and set up table view cells. But as an example, if you are just maybe in the background, behind the scenes, like downloading like their entire iCloud library, that's kind of a bad example, but you're just like downloading a ton of information, there's no reason that you can't just not have that merged at all. Like you can have one context be in one state with hundreds of objects and one be in a completely other state with one or two objects. That's fine.
So is the merging only relevant to information that the main context needs, and it's actually written into the code, and it'll merge only part of it?
Yes, in this case, yes.
Okay.
There are definitely other cases when you want to merge, and we'll look at that in just 1 second here.
Gotcha.
But yes, in this case, that's pretty much it. Any other questions about this before we move on? Okay. This is the core data stack that we're going to be using today. So we're going to kind of look at another one on just a conceptual level. We're not going to write any code for it, but this would be sort of a different use case of having multiple contexts. So this is what you would call the parent-child context sort of setup or paradigm. The best way that I can describe this one is if you have an app that, for example, is like a yeah, I mean, well, I usually say like a word processing app, but so as an example, like if you ever use like Microsoft Word or Apple's Pages or whatever, it's just, a text editor, right? But you can do things, you can undo, you can redo. You've kind of got a lot of things going on where you can go back and forth and you're like, hey, this is good, or maybe this is not good, or whatever. And we are going to treat one of these contexts more of like that sandbox or scratch pad that we kind of talked about on Monday. So we could say that this child managed object context is used for sort of the word processing. So like undo, redo, etc. While this one could maybe be for like just other objects in the app. So like, I don't know, just because I'm having a hard time thinking about it, we'll just think of tasks, because we know that that's just like, something that we've used before in core data. So what I want to point out with this is we use this to be able to use this undo and redo functionality that comes for free basically with a core data stack. So let me kind of go to the documentation here. if you look at NS managed object context, oh, shoot. Okay. Well, there are these undo, redo methods, and it's like basically free. So as an example, let's say we make some tasks and then we delete those and we're like, oh crap, undo that. Like I actually did want those tasks. You can make an undo button and you just call this undo and it would put those back where they were. Like it's like free undo redo. So going back to this, that's kind of what I mean here. So we could be making changes over on this sort of word processor, right? We make some changes. We're going to write some notes and stuff. Then we're like, no, I don't want that, kind of, undo that or whatever. Or clear it out even. You just say, I want to start from a complete scratch. That wouldn't affect anything in here. If we remember, when you call, for example, save on a context, it saves everything inside of it. Or if you clear a context, you reset it, it clears out everything inside of it. So if you've got some things that over here, like some settings or some tasks that you're using to display to the user or letting them, change them or whatever, you don't want those things to get cleared out when you want to clear out this context down here. So having them be separate things sort of makes it so that you can have one be, in a sense, more of a more of like a managed object context that we've been using today, which is just to save things. But then you can have this child context be the one that is treated more as like a sandbox where you can do whatever. And however you mess with that, whether you undo, redo, clear it, save it, or whatever, that doesn't directly affect anything that's going on with this parent managed object context. It would be like if you cleared out, everything in your Word document, that it deletes all of your settings or something in the same app. Like that wouldn't really make sense. So keeping them separate is, in this case, a good thing.
So in the previous model, the parent was the persistent store coordinator, correct?
Yes.
And the MOCs were both children?
Yes.
Oh, I see.
So now the persistent store coordinator is the parent of the managed object of this first managed object context, but then the parent of this context is just this context. And so the parent can be basically anything. And so in this case, we have two different parents here, if that makes sense. So it's not like you directly, let's talk about that. Let's kind of think about some implications about that. Okay. So let's say we do make some changes on that word processor and we hit Command S, we hit save, we're ready to go. We want to actually, have that be saved to the document or whatever, or in our case to core data. When we call save, what happens is that doesn't go immediately into the persistent store, but it just goes up to whoever its parent is. And it turns out, and it just happens like if the parent is the persistent store coordinator, then it will coordinate and throw it in the persistent store. But if it's just another parent managed object or context, then those changes get just thrown up here. And so maybe the parent managed object context also makes some changes, and then those changes go up to the persistent store when we call save on that sort of parent context. And then those actually get thrown into the persistent store.
So is this a better way of doing that, or is this just a different way of doing that?
Just a different way of doing it. It just really depends on your use case. I would say for most things, for most apps where we're just fetching some network data, the first way is probably better. But again, if you want to treat things more like a scratch pad where things are editable, you can get undo and redo for free, and you don't have to manage that, which it would be a pain to be managing yourself. This is a great setup to do instead. So there's one thing that we need to do though, which is if we want for whatever reason, it doesn't really make sense in the context of like the word processing app, but maybe the parent managed object context makes some changes and the child needs those changes. What you need to do is you can, like if you save those, it just goes up there. But if you don't, then you can either call your context.reset and that will throw those down. The child context.reset, or that's sort of the old way of doing it. Or you could just, again, put the child manage object contexts automatically merges changes from parent to true. And as soon as those changes get thrown down here or made on the parent, they get thrown down to the child. So either way kind of works best. The automatically merges changes from parent to is just way easier, but in theory you could call reset if you needed to. So kind of going back to Austin's question, which stack is the best? It kind of depends, and that's what's hard. I would say just use, a normal stack. Like even like what we've been doing up to today. It's not like you always have to use 2 managed object contexts or more. There's nothing saying you have to do that. If performance becomes an issue, then I would say use the shared persistent store coordinator, right? So this first one, because you can do things like separating out, where the saving is happening and your view logic. So there's no sort of fighting for time on the main queue. Otherwise, if you want to. If you want to have something where you can use things as a sandbox, then the second one is great. The parent-child contexts. So it depends, and that's the hard part. So are there any questions before we kind of switch gears a little bit and talk about concurrency related to core data? Okay. All right. Are we feeling okay? Do you guys need a break or anything before we continue with this second part? We good? All right. I know these can be a little boring. I try not to make them super boring, but I totally get it. So let's talk about core data concurrency. So we've talked about concurrency in the context of networking before, right? Where we've said, all right, well, if we're going to fetch some information from some source on a server somewhere, we don't know how long it's going to take. We need to put things on a background queue so it doesn't halt up the main thread and the main queue, and just make our UI slow. This is also a consideration with core data. Like I said, if we sort of blow this out of proportion and like think of the sort of edge case where you have to save hundreds of megabytes or even gigabytes of data into your phone's hard drive, it's fast, but it's not probably that fast. I don't actually know how fast you can write something to the device's storage. That would be interesting to find out. But it's definitely possible to make it so that something takes longer than milliseconds that it would be for you to not, or for it to lag up the UI. So there are basically 2 types of concurrency. And these concurrency types exist on a managed object context itself. So there's this main queue concurrency type, which would be like our main context or view context that we've been using up to now. And there's also a private queue concurrency type. So that would be saying, hey, this is just on some background thread, background queue. It doesn't matter which one it is. We just know it's not the main queue. And then there's this confinement concurrency type, which is deprecated, so we don't use it anymore. But that would be used if you were sort of using this thing called thread confinement, which is not very common. So they're getting rid of it. So you don't really need to worry about that. Let's talk about what I want to do is actually does anyone know what the term thread safe or thread safety means? Has anyone heard of that before?
I think I have an idea of what it is.
Okay. Yeah.
Does it have to do with does it have to do with what thread that something's running on and making sure the right things are running on the right thread? So for instance, UI running on the main thread and other things running on like the other threads that are, you know, less important
Yeah.
or lower priority.
Yeah. So that's really good. That's great. Yeah. Thread safety is the concept of if something is not thread safe, then it needs to be used on like a specific thread or queue. So like you said, views are one, right? It'll yell at us and even crash the app if we try to reload a UI table view not on the main thread. It's pretty picky about that. And so that would mean that our UI elements are not thread safe because they shouldn't be accessed from another thread. And it's sort of this whole general like what happens if you don't access it from the right thread. It sort of depends, and there's just all of the, it could be as benign as something not working right to it crashing your app, or maybe corrupting memory on sort of the extreme end. So there's kind of this whole thing that goes along with that. It turns out that managed object contexts as well actually are not thread safe in theory, and this is one of the more like benign, like it doesn't really like do a ton, but there are implications with it that are probably more having to do with performance and making sure that everything runs correctly. So as an example, what I want to do is I'm going to give you this little line here, and I want us all to go ahead and use it, and we'll see what this is going to do. So go ahead and copy that, and then come with me to just open up your same tasks project that we've been working on this whole week. This is the coolest, I think, core data tool. Well, it's like the only core data, well, it's a core data tool. It's a really cool tool to let us know, are we doing things on the correct thread as far as using our managed object context go, and using any really core data object. So our tasks, for example, would be a core data object. So once you've got that, go ahead and go up to where you select the simulator, but click the thing to the left of it where it says tasks, and then go to edit scheme. And it'll pull up a window that looks like this. It should kick you onto this run sort of tab here, which is what we want. Go to this arguments section. If it isn't there already, it probably is for everyone. But and then this arguments passed on launch is where we're going to just hit this plus button, and then it'll give us a text field. And all I want you to do is just paste that right into there. What this does is it's essentially making it so that our code is going to be, or the compiler is going to be very, very picky about our core data code. So if we're doing something incorrectly, then it's going to crash and tell us where. So even though our code was 100% working yesterday, as soon as we run this, it's going to crash on us, which is a good way for us to debug because it'll tell us where it's crashing.
Should we always implement this when using like core data and stuff?
Honestly, I don't think it's a bad idea to just throw it in there because it'll make sure that you do things right. So there's nothing wrong with it. I don't know if there's maybe a performance implication, like I would maybe take it out when you're going to ship the app to the App Store, but as far as development goes, yeah, like run it all the time. Okay, so there we go. Our app was completely working yesterday, but now it's crashing on us. So we see a couple things. You should, if you've added that correctly, it would say this. Core data annotation, multi-threading assertions enabled. So if you see that, then it's working. And if you don't, then you may have entered it wrong or in the wrong place, and let me know if that happened. But we see that this is crashing here. So I wonder if, just from what we've talked about here, if anyone can spot why you think it's crashing at this line here. Has something to do with our context.
Is that because everything's being ran on the main context?
Yeah. And we see that here it crashed on thread 2, which is not the main queue. It just happened to be the next thread, but it could have been any background queue. So what we need to do is say, okay, well, we either need to put this on a background context, or what we can do is say, let's just sort of switch over to the main queue to call this fetch. So there is a really nice, it's less applicable for the main context, although you should always do it. But basically what it's really the thing is, we need to run the context.fetch on the main queue because context is the main context. So that's ultimately why we called it like main context, to help you think, oh, I need to do this on the main queue. That's really the only reason we renamed it as well.
Sorry, but what file are we in? I can't find this area.
Oh, in the task controller, sorry. Just so you guys know, sometimes like the file that's selected over here isn't actually reflected, like isn't actually the real file I'm in. If you look up here though, it will always show the right file. So just so you know, I've noticed that like sometimes when you jump around, the selection on the left doesn't actually change. So as far as making this just run, we're going to run everything on the main queue for now, and then we can change it to actually run on a background queue or on a background context and queue correctly. But we can at the very least make it not crash. And all we have to do is say, okay, well, we're on thread 2 right now, so let's go to thread 1. And there's this handy, if we call context, there is this perform and wait function that will let us, so it says, performs a given block on the context queue. So whatever dispatch queue that context was created on, it will jump to that and let you run a chunk of code on the right queue. And that's essentially how you make this context thread safe. It's not really thread safe because you can't just call it from anywhere. But so as an example, let's just call perform here. And just because of how this is kind of working, so that we can access the these existing tasks elsewhere, like it's going to yell at us down here. Let's just say var existing tasks, be an array of tasks that's empty, and then we can just say oh, you know what? Here, let's do this. Sorry, I'm making this more complicated than it has to be. Go ahead and just undo everything we just did. Sorry, I'm being a little bit overkill here. Let's just do this whole thing in. So pull out the context from this do, so it's just outside of it. And then we can call, let's just do context.perform. I'm going to say perform and wait, and I'll talk about the difference here. And then I'm just going to delete this last curly brace that comes with it, and then throw that like below the catch statement, so that whole do try catch is just inside of this context perform and wait. So it should be, you can just add one right after this catch statement. So if I indent this, it's going to look like that. So I'll put a breakpoint right where it crashed, and let's run this again. It's going to crash in another place, but we can at the very least see when I hit 97, we can see we're back on thread 1. Oh, here, let me actually do this. Yeah, this will illustrate it better. Okay, so we're on thread 2 right now, and as soon as we say, hey, context, perform, and wait, it kicks us over to thread 1, because it just says, I'm going to grab whatever dispatch queue this context was created on and thus should be used with, and throw you over there. And so when we hit this, it's totally fine. There's no crash anymore right there. When we talked about networking in, when we talked about like dispatch queues in the networking sprint, did we ever go over the difference between sync and async? Do you guys remember? Or do you want a refresher? if we did, then we could definitely. What's that?
A refresher would be nice.
Okay, cool. Let's do that. And then we can kind of talk about why I want to talk about this. So if we have a queue, so I'll just say like let my queue equal dispatch queue. Doesn't really matter. If we say queue dot async, we print, I'm going to say like, let's see. Let's do this. Okay. So if I do this and I say, hey, I'm going to do something asynchronously on my background queue that I just made, I'm going to start the timer, and then after 1 second, it's going to say that it finished the timer. If I put finished work, what I want this to do is to print after I finish the timer. But what's going to happen is it's going to print it right after it starts. And I don't know why it's not printing finished timer, but that's not actually, that's weird. I wonder if it's just not here. Playgrounds are always a little bit iffy. Let's put this in muted load here. Yo, dude, that should run. I don't think I need to fire it. Okay, I guess I do need to fire it. I wonder if they changed that behavior. Which would be really interesting. Okay, well, what I'm trying to illustrate here is that it's going to print starting timer, then finish work, and then it'll go back and print the finished timer just because it starts this. And if we say async, it says, hey, you're totally fine to continue running code below this. You don't have to wait for this whole thing to finish before you continue running code. Whereas if I do sync, it changes a little bit where it says starting the timer, then finish the timer, and then only after that can it finish the work. It just basically won't run any, like, line 11 here until this whole closure finishes doing whatever it needs to.
So is this a way of actually like changing or manipulating a piece of data without anything else working on it? Like if you did it, I guess did the opposite, like you did sync just now?
Mm-hmm.
So if you did async, would that say no? That I'm confused. Sorry.
You're good.
Does sync mean that each thing has to wait its turn, or does async mean that you don't have to wait? The next object can the next process can start.
Yes, exactly. So sync says wait until this closure finishes, before continuing running code below it. And async says, let's run this asynchronously or multiple things at the same time. You can kind of break off and do more than one thing. We can say, basically, the code below the closure can start running even if the closure hasn't finished its work yet. That's kind of what we mean here. So there's like sort of a hard stop here where there's basically this line where it says you can't cross this until all of this work finishes. Or if we say async, it's like, yeah, it's totally cool. Like I'm gonna start running this work, but it maybe only gets to like the starting timer by the time that it starts running this code below it, and that's totally cool.
Okay, I have one more question, and I hope I'm not like totally too far off base by asking this.
Okay.
But maybe I'm misunderstanding what a closure is. But is a closure like a special type of function that says when you're done, do this? When you're done completing this task, do this? Like
No, that's one use for them. That's the hard part, is closures are just a chunk of code. So a function is a closure. A closure is a closure. A completion closure is a closure. It's just more than one line of code, right? It's just like a chunk of code that you run sort of together as like a block of code that you run. Does that make sense? So it's not like this is saying wait for something. It's just saying like, hey, I'm going to, here, let me do this. So if we have,
Spencer?
Yeah.
Back on his question, because from my memory, right, like every time we use closures, it's always has to do with like executing code asynchronously. So you know, because I was going to ask the question, well, does async only work with like with closures where we use them asynchronously to execute one code and then wait and then to execute another code, or are asyncs just used whenever we want? Because I always thought that computers don't really multitask; they just do things, you know, really fast, jump from one to another really fast. But right now, what you're saying, it seems like, oh, you're doing one thing and then you could execute another thing at the same time. But
Yeah.
are you saying that they're on different threads?
Mm-hmm. There's both, actually, and it depends on the processor, essentially. So if you have a multi-core processor, like any modern computer does, and also iPhones now, if it has more than one core, it can literally at the same time be running more than one thing, as many cores as there are. So if you've got 6 cores in your processor, you could be running 6 things at once. And then on top of that, you also have what you're doing, what you said, which is switching between, you know, processes or threads very quickly. That's called time slicing. And it's sort of like fake concurrency, where it's like they're almost running at the same time because it's switching around different threads so quickly. That, I don't think you need to worry about that too much here, but that's essentially what's going on.
Well, I'm just trying to understand, you know, sync and async, because it seems like with multi-thread, right? Mm-hmm. Even if it's sync, there might be a possibility where it does split off. Yeah. Or does it just wait until one process is finished before it does another process? Like even if there's multi-cores.
Yeah, even if there's multi-cores, it would wait if it's sync.
Gotcha. All right.
So I'm going to try to illustrate this. I don't think this is quite going to work the way that I want it to. But let's say we have our code running from lines 1 to 8 right here. And line 8 is the point where we say sync or async. So what that would mean is if let's actually think about sync first. So it's sync right now. What that would mean is we're going to say, okay, now I'm going to split off and I'm going to jump to my background queue because I'm saying queue.async, that's not the main queue, it's just this one that I made on line 3. So I'm going to jump up here and do some work. And then we're going to come back and do the rest of the work, like the print finished work on the main thread. So we kind of go like that, if that makes sense. As far as async goes, this would be more like, instead of us having to wait and us just sitting here on taking, this is hard to draw. Instead of us taking like these 8 lines of code worth of time that we're just not doing anything, instead what we could do is we could say, well, I am going to start running lines 8 through 13. So I'm just going to say that's like 13. But at the same time, I'm going to start running line 16 here as well, because that's just something that I can start running on the main thread. And now this is where it like kind of blows your mind. It's a little bit hard to think about because like it's not a linear amount of time that's happening. Now it's like literally 2 lines of code are getting run at the same time, or very close to the same time if like, time slicing is the thing, but you don't really have to think about that. But it's sort of like we skip this whole waiting time and just kind of say, well, we can just like run line 16 right now. We have a thread that can do that. And that would be sort of how the async is working. Does that kind of make sense? Any questions on that?
Yeah, it makes sense.
Okay. So going back to our code here in our context, perform and wait, that's all we're saying. If it's perform and wait, we're saying that this is like sync, and if it's just perform, it says do it asynchronously. And you can see this in this line that it gives you. Perform and wait synchronously performs a given block on the context queue, or perform asynchronously performs that. So behind the scenes, I'm sure that this function is literally just calling like whatever the queue is .sync or .async and giving you that closure, and that's about it. But it just keeps track of which queue you have, which is important. So the implication here, if we say perform and wait, is that you can't finish the function or you can't run any code below it until this is all done. Or if we said perform, you could. And for this, honestly, it doesn't matter, but that's sort of the implication here. Okay. Will you, I know we've talked about a lot already. Will you give me a 1 to 3 on how you feel with I guess it would be, well, here, let's ask this first. Can you give me a 1 to 3 on how you feel your understanding of perform and wait is? Like what it's used for? And if you have any questions, please feel free to ask. If anyone's feeling brave enough, I'd love a quick, concise explanation of what perform and wait does. Okay, that's okay.
Is perform and wait just perform this chunk of code and do nothing else until it's done?
Yes. Yes, and I would say on top of that, just doing it on the right thread or dispatch queue that the context was created on. That's the biggest thing, is that when we say context perform or perform and wait, it will kick us to the right queue that it needs to be run on. So for example, if we're trying to call context.fetch on a background queue where this context is our main context, it needs to be run on the main queue. And by way of doing perform or perform and wait, we put our code running, that code to run on the main queue. And we know that it'll run on the right queue. And you can see that, like, even with the annotation, the multi-threading assertions sort of enforcing very strict core data code, it's running fine and it works completely fine. We could, if we really wanted to, we could close the app, delete it from scratch, and everything should work fine, I think.
And all that is done automatically, right?
Exactly. Yeah. And the best part about this is you don't have to think about which thread you need to put this on. You just say context, perform this code, and it will just make sure that it does it on the right place for you.
Okay, so as far as making
So
thread safe, we could either use perform or perform and wait depending on the situation.
Yes.
Okay.
Yep, exactly. And this, you just think perform and wait is like sync, and perform is like async.
Excuse me. I just wanted to. I'm trying to figure out why it's so tricky to like put it in a map for me. In the playground, it's a little bit easier to understand based on it's going from top to bottom. I know where it's going to stop and what block of code it's going to do at that time. And if it's going to run one block of code and continue the other one at the same time, or it's going to do this one first, and once it's finished, then it's going to do the next one. But I think it's hard to implement it the same way when we're talking about the context, because I guess I don't know in what context we're at and in which one's gonna do what before it stops and then finishes and do the next step. Like, I think that's where I'm getting a little confused.
For sure.
Like knowing in what context is performing what and in the other one performing what. Yeah,
no, definitely. In this case, context is always referring to the main context. So whenever you see context here, it's the main one. Really all we're doing, like really all context perform and wait or perform does is it says go to a different queue and do all of this code on the right queue. So just thinking about this, we're basically, if we jump to this main context, the main context is specifically said, it's basically, sorry, it was made to be used on the main queue. And so whenever you want to use it or anything that was made on this main context, you have to use it on the main queue. As far as like, where we would put that, it's literally if you don't know where to put this stuff, the good part is you just say, all right, well, I'm going to throw that concurrency debug on, run the code, see where it crashes. And then from there, you would just kind of go up the line and say, okay, well, what is this context, right? Like if you don't know what it is, you just go up until you say, oh, it's this main context, and it's probably yelling at me because I'm doing it on the wrong thread. And then from there, it's just a matter of you just saying, all right, well, we can call perform and wait, and that should fix it, or perform. I know that seems like fairly nonchalant and probably sounds harder. Well, yeah, I think it sounds harder than it is after you get some practice with it. But I understand, like, at this point, you're probably like, I have no clue where to put this. But it's really as simple as run the code, see where it crashes, and then look at the context that you are using where it crashes, and then just make sure that you're running that code on the right context or on the right queue by just calling perform or perform and wait.
Also, in this situation right now, is queue and thread used interchangeably?
Yes. They're not the same thing, but you'll have an entire lesson on concurrency, actually 2 lessons on concurrency, where we do eventually break them up. But if at this point I refer to them as the same thing because for all intents and purposes, you know nothing about the lower levels of threads or queues, so it's not really worth, I think, mixing them up. Or it's, at this point, there is no difference, so I use them interchangeably, yeah. But there is definitely a difference. All right, let's take a break, and then we'll come back. We're going to finish the presentation. I've just got like 1 or 2 more slides, and then we'll make this work with multiple contexts now that we kind of understand a little bit about perform and wait. So see you guys in 5 minutes. All right. Welcome back. Wow, that's loud.
So Spencer, for my first question, I asked you like if 2 would be plenty MOCs.
Yeah.
Well, the next model is where I guess you could use multiple ones as long as it's in that parent-child context form.
Sorry, how do you mean?
So again, like if I wanted to have multiple pages or scratch pads where users are inputting information, that's when I'd use that parent-child context.
Yeah, for sure. Yeah, definitely. That's a great time. So really this comes back to if what we just looked at with using context, perform and wait goes, there's only one rule about using core data when you have concurrent code like we have with networking and stuff. It's really easy. Don't use core data objects outside of perform or perform and wait. That's pretty much it, and that'll solve all of your problems essentially, which is the good part, where you don't need to worry about too much other than, if something's not working, and especially if something's not working with that concurrency debug flag that we put in the arguments, just run through, test your app and put perform and wait wherever you have a problem. Or, obviously you're more than welcome and encouraged to do this from the start from, with your next project. But, really it just comes down to using perform and wait. So let's go ahead and pull out, I'm actually going to put this back the way that we had it. Perform and wait. Okay, so now we should all have the same code. I'm just going to make sure this runs again. Okay, so, but like we talked about, the whole point of using something like this shared persistent store coordinator is so that we get off the main thread. What we were doing was we were doing some networking. We're on a background thread, and that's awesome. And then the code that we just added made it so that it kicked us back onto the main context. So we would be saving things on the main thread. And again, if we're saving a lot of data, that would be where we would start to run into issues if it took a long time to save. So all we really need to do instead of when we say like context equals core data stack main context, we just need a different context. The cool part about this is it's actually quite easy to make a background context as of now with this NS persistent container that we have in our core data stack. So the first thing I want to do real quick is jump to the core data stack, and let's add that line so that the main context can merge those changes when our background context is going to save whatever we get from Firebase. So we're just going to say container.viewContext.automatically merges changes from parent equals true. So it says it indicates whether the context automatically merges changes saved to its persistent store coordinator or parent context. So either way, whether it's using sort of the first where its parent is directly a persistent store or the parent-child context, it will still merge those changes. It doesn't matter who the parent is. And that's all we need to do as far as any setup with the merging goes, which is awesome. We're going to need to come back here, but we're going to have it not work first. So instead of, and basically the reason we wanted to make this context as a constant is we're using it in a few places. We use it in this perform and wait. We use it when we fetch, and we use it when we actually create a task. So everything is sort of directed to the main context, but as far as changing it to be a background context, it's really as simple as saying, all right, well, let's go core data stack shared. And instead of main context, we're going to ask the container for a new, if I can spell, background context. And that's all you have to do, which is awesome because there's no setup necessary. You don't have to give any information. This is just saying, I want a new manage object context, and I want it to be on a background queue so that things don't get locked up on the UI. And that's it. Sort of. Well, things are sort of going to work, and I'll show you what I mean by that.
So what's the scope of this new background context? When our context variable here goes away, does that also get rid of the new context?
It does, yes, and that's why I said that this is a little bit weird. But it's like there are times when you're not fetching anything where really only the view context is going to exist. But whenever we want to save things on the background, we just say new background context, and that's completely okay. It's not sort of an expensive operation to just spin up a new context whenever you need, and then just release it from memory. So it's not a bad thing to, every time you fetch this, to just create a new background context. Just for the length of the function, it gets thrown away. You fetch it again, it'll make a new one. And you can do that as many times as you want. But yeah, the scope is just this function. So let's go ahead and run this. And what I want to do is, it might not quite work if what I'm going to do is delete the app. You're welcome to do this with me, or you can just watch. But you'll see that it's crashing somewhere else. Because we've got these assertions enabled, right? It's being pretty particular and picky, which is good. So what do you think is happening here? And if we look back from where that was called, I don't know if you've ever done this before, or if anyone showed you this, but you can actually, when you're on a crash or a breakpoint, you can kind of go up lines of code to previous lines of code to see where it was getting called at. So I can jump back here to this closure number 2 and say, oh, it's getting called in my update task function that we were just looking at. So right after we set the background context, do all of that filtering and sorting or creating and updating of tasks, we call save to persistent store. So why is this crashing?
Is it because we are saving to persistent store, we need to save to the context?
We're saving, yeah, I mean, the name save to persistent store isn't the problem, but we look at this and we're saying, oh.
In the arguments passed, I meant, for the save to persistent store.
Oh, yes. Yeah, exactly. So the main context here, we can see, well, it's getting mad at us because we're on thread 3 now. When we made a background context, it's just going to be running all of this code on a background thread. And it doesn't matter what background thread, but as soon as we call save to persistent store, we're saying, hey, save the main context, not that context that we just created. One, it's crashing here. If we turned off the assertions, it would just not do anything. So just watch me here. You don't have to do this. I'll just turn this off real quick. And you'll see that it's like nothing's happening. It's like our app is broken. I know things are getting fetched, but they don't ultimately get saved. So let's think about this. It would be like if we just made those changes on this background context here, but then if we call save on our main context, it doesn't have any changes at all. And so we're just saving the wrong context because, if we make changes on a background context, we want to save that background context, because until we save the background context, 1, this view context doesn't get those changes, and 2, they're sort of unrelated. So we're going to do exactly what Austin suggested, which is we're going to go and just modify this function. I'm just going to actually call it something different. I'm just going to say save context. Doesn't manage object context. And then just to make sure that we don't run into any issues where we could be trying to save this context on the wrong queue, let's just call context.perform_and_wait and do this whole function in here, just this do try catch. And we'll be sure that we're doing it on the right queue and we don't have to worry about it. So now we can just, instead of main context.save, just call context.save and then context.reset in the catch.
So that ns manage object context and argument pass doesn't have to be, it knows it's our core data stack, .main context.
Mm-mm. No, now we're just making it so it'll save any context at all. It could be the main context, but it could be a background context as well. So once you've got that, we'll jump back here. And if we try to build, oh, sorry, I keep turning off live issues when I work on my personal stuff. So now it's going to yell at us in a few places. So all we have to do is just say, all right, well, let's save our background context. And this is it, like if you just look up here, it's still the same new background context that we just made. So inside of the perform and wait, we call that save, and we're actually saving the context that got all of those fetched things from Firebase. So I'll turn this back on. And then the other two places that it's yelling at us is down below. If we look at our create and update, those just also need to be changed as well. So I'm just going to say shared save context. So we're passing a context into the create task, which is nice because we have to give it a context here. The update task, though, we're not. We're going to somewhat naively assume we've got kind of two choices. We could say that when we call this function, we're going to pass it a context, or we're just going to sort of naively assume that it's going to be the main context instead. Yeah, let's not be naive. So I'm going to include sorry. Oh, this is hard. Yeah. Let's include a context into the update task function, and then we can call save on that context. And that just means we need to update somewhere else, but we can pass in a context now. Whoops. There we go. So now it's going to yell at us in the detail view controller where we actually call this update task function. So here I'll do the same thing. I'll just pass in the core data stack shared main context, but at the very least now I have the opportunity to pass in whatever I want. Okay, so let's run this now and look at what we have. Now everything should work right. Let me go here. Sometimes this works, sometimes it doesn't. Just kind of depends on what queue the context is made on, but sometimes you can see it. So normally it just makes the same context. So, okay, so what we've got here is when we run this, when we perform our fetch function, we call update tasks right here, and it just happens that we're on thread 4. So when we make this new background context, it's just going to choose a background queue, just anything that isn't the main queue, to have that be like its sort of designated dispatch queue. Most of the time it's the same thread as like what we're on right now, but sometimes it's something different. So I'll jump into here. Yeah, it's still thread 4. But if you run this enough times and if you have complex enough code, then it will probably assign it to a different thread. So I'm just trying to illustrate that like perform and wait is, even if it's on the same queue as it already was, it'll still work fine. Or if it's, we're on thread 6, context queue is thread 4, then it will kick us onto 4. Oh, excuse me. So at this point, we can just run through here and just make sure that everything is working, which it totally should be. Make sure that we can still save things correctly. Fetch them. But at this point, that's actually everything. This is like the one project where we tend to finish early, which is kind of nice. So I know this is like, really, we just basically did like 2 instances of perform and wait. And that's not a ton of exposure to it. But really, when you're doing this in your afternoon project, just remember this rule, right? Don't use core data objects outside of perform and wait, and that will solve your problems. So like Austin said, it's honestly not a bad idea to just have this argument on all the time, as long as you're like in development. It's just going to help you know, am I doing this right? And you can be sure if it's not crashing when you have this concurrency debug wrong, if you're specifically your core data code isn't crashing, then you should be okay and it should be performing well. Now, like we saw before, we added in the background context. Just because it's not crashing doesn't mean that you're doing things the totally best way. Where here now we are making sure that any potentially long processing or long saving operation is going to happen on a background queue and not messing up the main queue. Okay, can you give me a 1 to 3 on how you feel with what we've done with the code as far as making a background context goes and using that as opposed to using the main context? Okay. What can I clarify? What would you like me to go over again?
For simplicity's sake, couldn't you, again, the arguments passed for that function to save, make sure that that manage object context is the core data stack main context instead of having to put those in the functions below in the controller? That makes sense?
No, not quite. Right here, do you mean?
No, if you go down to your CRUD methods.
Yeah.
Because in your CRUD method, you're calling save and having to pass in that context.
Mm-hmm.
Then you just go back in your core data stack and make the argument passed be your core data stack dot main context.
You mean
instead of having to add those in the CRUD method?
You mean right here? Like when you create a task, you just initialize it with the main context?
No, in your core data stack save, when we change the save to persistent store, just saving it.
Oh, do you mean like right here?
Yes.
Sure. So you don't have to pass one in. I stopped teaching where I add a lot of default arguments into the context because honestly, I think it can be more confusing when you've got default arguments, default values for your arguments, because it can make it so that you don't quite see that there's a problem with your context until you use the concurrency debug and have it crash. So I almost enjoy having you and me do a little bit more work, and I would even do this in my own code, where I manually have to put in the context because I will be conscious of what context I'm using instead of sometimes forgetting like there's a default argument, because I 100% done that before.
Yeah, that's what I was mainly wondering, if like we should do that kind of for just better use case scenarios.
It's up to you. Like I said, I would just almost err on the side of like doing a little bit more work for yourself up front, because I think it'll save you time ultimately with you probably having to do less debugging, specifically related to concurrency and core data. Okay, what else can I clarify? Because I see that a lot of you are giving me like 1 point whatever 2s, and that's great, and that nothing necessarily wrong with that, but I like us to get a little bit more comfortable. So what can I help clarify? If you want me to draw something out, if you want me to go over some code, if you just want to ask a question, please go for it, because we have plenty of time.
Can you just go over where you made the changes in the code?
Yes. Really, it comes down to the main changes that we made are we are doing these two lines here, and by extension, like the ending curly brace here. But we're essentially running all of our processing and, yeah, well, really, okay, so we make the background context here. Then we call context perform and wait because we're going to be using that context in a couple places inside of this chunk of code. So one is when we perform a fetch request. So it would be sort of like us, because we're saying background context, it should perform the fetch. So if we have the changes up here in core data, instead of them going to the view context, we're instead saying, no, I want you to fetch them to my background context. Again, so that even fetching doesn't hurt any performance or have any performance issues with the UI. So we're fetching things specifically to here. Then, that's kind of annoying, but we'll deal with that. So then we also use it, so we get our tasks out here. And so those tasks are just chilling on the background context. So then we update them, and then we either, we update them, and then we also create them using on that same background context. So we, create some new ones or whatever, update some old ones, whatever, and then save that back to the persistent store. All the while, none of that long processing work is hitting the main context, but we still do get the added benefit of the merge happening. So when those changes appear, those get merged over and the, to the view context so the fetch results controller can see them. Does that kind of help? Was that not really what you were asking?
Well, you went kind of fast before it. So, I mean, when you were telling us where to change the safety persistent store,
yeah,
what codes to actually change it to, I kind of missed those.
Oh, I see. So that's, yeah, okay. So that's the first part. And then the second thing that we changed is the save to persistent store right here so that it looks like this. So I'll pull this back to the original way it was and then show you. So this is the new way right here. Really all we're doing that's different is we're saying, all right, well, now we're using more than one context. So I don't want to always be saving the main context. Instead, I'm going to say, I will pass in the context I want to save, just whatever context that is, into this function, and then we'll say that we save that instead. And to make sure, again, that we're doing it on the right thread, so we could call, save our background context from the main thread, and that's fine because it would kick us to the correct thread because we're using perform and wait here. So we wouldn't have an issue with that at all. So let me know when you've got that, and then I'll jump to where we changed it just a little bit more.
Yeah, I got that part.
So then all we did was we changed it. If you try to build this now, it probably won't build unless you've already made these changes. But we just say we're going to save the background context here in this same update tasks with representation function at the end. And then at the very bottom, we had to create an update task functions, which also use the save to persistent store. So we just passed in the context from the create task, and then we changed the update task so that it itself has a context that is passed in so that we can call save context and give it one.
Could you go up to just right before the enum?
Mm-hmm. Right here?
A little bit up, a little bit more. Yeah, just right there.
Okay.
Yeah. Okay. I got it.
Okay. Other questions?
So just to clarify, the reason we're using a different thread for updating is so that it doesn't like cause the UI to lag, but then the reason we are using the main context and creating and updating tasks is because we always want to show the new created and updated tasks.
I mean, you're not wrong, no. Really, it comes down to, like, as far as this goes, we definitely could make this run on a background context, and that would be completely fine. There would be nothing wrong with us, saying like let new background context equal that and pass that in. At the same time, this is something where it's like you're saving one individual entity. There's no way that that's going to affect the UI in any way. So if you are sure that you're just saving a small amount of information, there's not really an issue with putting it on the main context. At the same time, there's nothing wrong with you also just throwing on a background queue or making a background context as well to do that. But no, it doesn't have any reason, or it doesn't have anything to do necessarily with because you want to show it on the screen. Really, the only thing that needs to be running on the main context here is our fetch results controller, because it's specifically dealing with UI, and so we need to make sure that its managed object context is the main context. Anything else in the app could use any context we want. Yeah. Does that kind of clarify that?
Yeah.
Okay, cool. Other questions?
I have a question.
Okay.
So on the task controller, when we did update tasks, so we save it on the different context than the on the update task function, or is it?
That's actually a great question. Let me see here. So you're right. If I understand what you're saying correctly, is we may have created this task on the main context. So if I say like main task, it's normal. Oh well, I guess then either way it doesn't matter. But then when we fetch this, it's going to be fetched on the background context. So if I try to save this on the main context, it's still going to work. The reason for that is because that merging is happening, and so it basically exists on either one. So either context can then save that task because it exists on both contexts.
So it happens just automatically.
Mm-hmm.
Okay.
Is that kind of answering your question?
Yes, and that's because of the one line that we added in.
Yeah, it's really just that one line that makes this all work. So again, if I like delete this here and I take out just that one line to merge the changes, you'll see that nothing happens on the screen here because it doesn't know that those exist. It didn't merge those over. When I run it again, it'll probably throw them up. But that automatic merging never happened, and so you would have to sort of manually perform a fetch request to the persistent store for it to see that there are changes.
Okay.
Could you show us the delete method for the CRUD?
Yeah, for sure. Yeah, we could definitely do that. So let's just say func delete task. Also, yeah, let's pass in a context as well. So the cool part about this is, like if we can just say perform wait, just make sure we're doing it on the right context, or on the right queue. task actually, you sort of get kind of some cool freebie functionality just because your task is a subclass of NS-managed object, and because NS-managed object is a subclass of NS object, which is basically the base class for almost everything in Objective-C. Like, it's super, super rare that you would ever see something that isn't a subclass of NS object. So like when you make, you know, a class or a struct, you just say like class person, you know, you never say that you don't have to say that it's a subclass of anything. In Objective-C, everything is always a subclass of NS object. And because of that, you get some cool stuff kind of for free. For example, there is like to remove something from an array of anything that's an NS object, you can just like call remove object and it will figure out the index for you. You don't have to find the location of that thing, grab its index, and then delete it on another line. It's like a kind of a one-line process. So for deleting, all you have to do is just say context.delete object, pass in your task. You don't have to find the index or anything. It's kind of nice. And then we can just call core data stack shared, save with our context. That's really all you need to do. So once you get that, we'll go ahead and throw this into the table view controller so we can actually have swipe to delete going on. Is this the one you were talking about or the networking? I guess we could do both.
No, that's what I was talking about.
Okay. Does everyone have this? Can we go to the table view controller? Okay. So we can jump down to, I'll maybe just put this under like the title for header and section, just so it's kind of grouped all with the table view methods. We're going to call the commit editing style function. Have you guys used the commit editing style before? Yes? Okay, cool. So we get like, there's basically two editing styles. Oh, well, three if you count none. Delete or insert. So what I'm going to do is I'm just going to say guard editing style equals delete, else return, because I don't want to do anything if it's return or if it's inserting anything. I, in this case, just care about just deleting cells. So what we're going to do is grab the task that we want to delete. So I'm just going to ask the fetched results controller for the object at my index path that I get from my commit editing style function itself. And then we can just say task controller dot delete task. And for the context, I'll just use the main context. Because that's where it's going to come from if we're using the fetch results controller. Now, normally, you would then delete the row for this cell or for this task. But if you do that here, the problem is it's actually going to try to delete the cell twice. The reason is down here in our fetch results controller, it's the thing that is deleting rows when there's a change. So it'll see that change and automatically hit this line 152 in my case to delete the cell. So all we have to do is just call the delete and save that, and then the fetch results controller will take care of letting the table view or know that it needs to remove that cell. So let's run this. It's not going to delete them from Firebase yet, but we can do that. It's a very quick function as well. But I can just delete one of these. And we can see here it hits my line 152 because it saw that I just deleted that task. And then it'll delete the cell. So just as an example here, don't do this, but I've definitely been guilty of doing this, and I've definitely seen students do this as well. If you delete the rows as well when you're using a fetch results controller, it'll give you this, and it'll say, hey, you're trying to delete more, let's see, number of rows contained in an existing section after the update, which it should be 2, must be equal to the number of rows contained in that section before the update, plus or minus the things that were deleted. So it should be 1, but you're deleting it twice. And so it's like, I'm not happy. Basically the data source for the table view is saying you need to have this amount of cells, but then the table view is like, no, I need to have this amount of cells, and they conflict, and then they just kind of explode and die. Like they're just not happy, so they can't decide on what to do, so it just crashes the app. So to fix that, we just let the fetch results controller take care of that, and then you can delete all day long.
Sorry, Spencer, could you repeat that, what you just said? I think I missed it.
Yeah, so when you...
Or just the fetched results part.
The fetch results controller takes care of deleting the cell? Is that what you mean, or?
Yeah, I guess I was just confused about what was happening there, but it's okay. I got it.
So the problem here is when we delete this task, normally if this is like a normal table view app where you don't have a fetch results controller, this is what it would look like, where you delete the model object and then you delete the row that goes along with that, the cell that goes along with that. The problem is if you delete the row here, it's going to try to delete it twice because the fetch results controller itself is going to see that there's a change, and when it says, oh, it's a delete change, it's going to call that exact same table view delete rows method. And so you delete that cell twice, and then the table view freaks out because it thinks it needs more or less cells than it does because you've deleted something twice, and it doesn't match up with what the data source says it should be.
So by using the fetch results, you prevent that from happening?
Well, when you use the fetch results controller, you just don't delete the cell. You don't call table view delete rows.
Oh, okay.
And that's all. Because the fetch results controller does it for you.
Yeah. All right.
All right, real quick, we actually definitely have time to just write a delete function to actually make it delete things from Firebase. It's actually really easy. So let's do that. It's basically about as long as it's actually shorter than our put function now that I look at it. So let's make a function and call it delete task from server. I'll just pass in my task. And again, I'll just do a completion closure that's like escaping, doesn't take anything in. Oh, well, not that. Returns void, and we'll just give it a default value of an empty closure. So for this, all we really need to do is, if I go back to the Firebase console, to my real Lambda email, what we need to do is basically figure out which task we need to delete and then go to that specific URL, like with this identifier, and then call, we just set the HTTP method to delete, and then it will delete whatever's there for this API. So what I'm going to do is I need to make sure that there's an identifier there. If there's no identifier, that means it's probably not going to exist on Firebase, for one, and two, then if there's no point, if there's no identifier, we can't delete anything. So I'm just going to say guard let identifier equals task.identifier else, call completion, and we'll return. Just, we couldn't do anything. So that should never happen. Otherwise, we can make our request URL, and we can just say we'll take our base URL, and we'll do dot appending path component. We'll do our identifiers UUID string. So we get Sorry, I'm doing things too fast. So that we get something like this, and then we just need to tack on that .json so it'll actually like let us modify the database here. So I'm just then going to say appending path extension with JSON. So once we've got the URL ready, we can make a URL request with the request URL. And all we have to do with this is just set our request's HTTP method to be our method.delete.raw value. Then we can perform a URL session data task. Actually, I'm gonna, we can leave the data, that's fine. And I'll resume the data task as well right now. Then it's very much like our put function. Really, all I want to do is check for an error and just see like if there was some reason why it couldn't delete it, that I actually know what that is. So we'll just say if let error equals error, we'll log that there was an error deleting task. We could even, like, if we wanted to, interpolate the task name so we know specifically which one it is. Although that's going to yell at us, so we'll do that. From server, and then we can interpolate the error. Call completion. Learn. Otherwise, well, actually, let's just do this. Oh, no, that's actually fine. We'll just call completion here as well. If we wanted to, it's somewhat redundant because we're not doing anything to call completion here as well. But I guess there's nothing wrong with it either. So now we just need to throw that in our delete function. Really, the only hiccup to this is we need to delete the task from the server first before we delete it from core data. Because if we delete it from core data, then it's gone, essentially. So all we're going to do is just, before we call context.delete, we're just going to call core data stack. Oh, wow, no, not core data stack, just delete task. Wait. What did I call that? Did I call it the exact same thing? Because if I did, that's a problem. Oh, delete task from server. Okay. We'll just do that. So now if we run this and we pull this back out to the larger view, we should be able to see if I delete like mine, it actually deletes it over here in Firebase as well. Okay, someone just deleted something. Are there any questions as far as the deleting goes, whether it's from core data or from Firebase? Okay, cool. Are there any questions in general? Like, well, can you give me like a 1 to 3 on how you feel just overall with everything we've talked about today? So using multiple managed object contexts and doing like perform and wait. Those are the big things here. Okay. All right. I think it's really going to be helpful for you guys to see this just in another project, just because we didn't do a ton of actual code today. So getting a little bit more repetition with actually writing out this code and seeing where to put things, I think is going to be super helpful. We've got about 7 minutes left. If you want, we can hang out for a few minutes and just chat about whatever, or if you want, we can go to lunch early, because I feel bad that we always go to lunch late. So it's up to you on what we do.
I'm kind of confused about work.
You're sorry? Can you say that again?
I'm kind of confused about how Build Week is going to work next week.
Okay, yeah. As far as Build Week goes, it's not really, I don't have a ton to do with it. Is there anything specific I can, like, is there any, yeah. Do you have a specific question?
Last time we had it, we just like selected from projects, but now there's like a whole sign up sheet for teams and things. I just don't really know how that works together.
Right. I believe, if I'm not mistaken, let me double check the calendar, but I believe there is a, oh, it's not today, it's probably tomorrow. There's probably a Build Week kickoff meeting after lunch, after the sprint challenge, that they're going to basically walk you through how to do, you know, all of that. There will be a kickoff to, well, I think it's been a while. Kat or Jonathan, can you guys speak to exactly how the process works? Because it's been a while since I actually sat in on one of those meetings.
Okay.
Well, now for some reason, since we got the list late, they're having like a draft because the projects ran out tomorrow or something, which kind of makes it a bit more complicated for people doing this the first time. Usually you can like pick which one you want out of like a list of 10 and order them. I want this one first, if not this one, this one. But since we got the list late, the projects ran out, it seems, and they're having like a draft tomorrow. So I assume you'll get assigned a project this time. I'm not entirely sure.
Interesting.
Okay.
But there are going to be meetings that are going to explain everything. Like the Build Weeks team will specifically go over things with you. And then I think there's sort of like an icebreaker meeting, if I remember right, to like get with your team that you'll be working on or working with through the week and sort of help you get to know each other and be able to kind of hit the ground running, if I remember right.
Yep.
Austin, you said that this time we don't sign up, we're just gonna get drafted? Because I see that James just posted saying that nobody has signed up yet, but I didn't remember seeing like a link to a sign up sheet.
Yeah, that's what I'm going off, is what James posted. But again, we didn't get the link till I think Wednesday, or if not late yesterday. So all the projects were already taken is what I'm assuming. And now they're basically going to draft us. So they're going to assign iOS developers to each project that needs it, or according to, I guess, the fulfillment. I'm not entirely sure, but I was just going off of what James also put there that you're reading.
Yeah, I just saw this. Sounds like James is going to get more information and let you guys know. I'm sorry, I don't have a ton of information. It's just like a completely different set of staff that deals with Build Weeks. So it's fairly hands-off as far as my interaction with it goes. So sorry, I don't have a better answer for you.
Yeah, the kickoff usually kind of answers all the questions you have, and it's pretty long. So if you're a first time doing it, they go over basically every question you have, if there's anything to worry about.
Yeah.
Okay, cool.
Yeah, it's pretty well organized at this point. It definitely wasn't like when we first started them out, but now you'll get a few documents as well on like what you should be doing, kind of a suggested sort of pace and schedule and everything, and sort of how to work with everyone. So you'll get all that information probably tomorrow afternoon, I would assume.
I feel kind of bad that I don't get to make a choice between 1 to 6 out of 5.
For projects.
Yeah, because they usually give you like 5 projects, and they want to list the ones that you want. But instead of only putting 1 and 2, they actually have you put 1 to 6.
Oh, gotcha. Yeah, I don't know. anyway, I'll make sure that we get that information to you as soon as possible, if not just by joining the meeting tomorrow. If you do have any concerns though, like after tomorrow's meeting before the weekend, let me know and I'll make sure that we get you answers. I'll probably have to go through someone, but I want to make sure that like you don't feel overwhelmed by Build Week. It's really a great experience. So.
Oh, Spencer, would you be able to zip up that Gather project and send it to us? Because I think I have a few typos.
Yeah, sure.
For anyone's time here.
Yeah, I will definitely do that. All right, guys. Are there any last questions before we head out to lunch on time finally? Okay. All right. Have a great afternoon, guys. I hope that you feel okay with today's project. It seemed a little quiet-ish, so I hope you're not overwhelmed. Please let us know if you need any help. Today is the day that I do have my meetings, so I'll be around, but it will be later in the afternoon that I'm available. But I would love to help you if you have any questions. So don't hesitate to reach out, and if anything, I just might say you might have to wait a little bit. So, but the TLs will be doing. They'll be doing their Q&A session too. So, all right, guys, thanks so much. Have a great lunch. Talk to you later.